Hello and welcome. This is the tutorial movie on how to connect the muxes, the training mux set. We got our digital optical power meter here. You can turn it on with this, and with this you can set it to the wavelength. Most of the time we put it on 1550, but this is just a correction factor of the value. It will read out 4090 light even with the 1550 wavelength here. We got our two pairs of CWDM 1 gig optics here. We got our two attenuators. These attenuators are needed to make sure that we don't overload the power in the receiver of the optic. And we got our cables, and we got one mux here with just a simple Cisco switch, and another mux over there with another Cisco switch. The first thing I will do, I will remove the dust cap, I will plug it into the Cisco, and then I will make a connection to the mux. The mux is a complete passive device, so there's no ventilation, there's no electricity, nothing. Here I've got my cable. With the cable I'll just remove the dust caps here, and I'll make a connection to it. Always read what it is. This is a 4090, so I'll plug this till you hear click, and I'll put this on the 4090 port. It's better to rewind it a bit, of course. Then I can use my dB meter and measure the signal, and you can see the signal is what is coming out is minus 0.62 dB. We will use the attenuators on it to block the signal a bit, otherwise the receiver on the other side will receive too much power. So we'll plug that on the COM ports. And on this COM port. The advantage of putting it on the COM port that all these ports are now blocked with 15 dB of power. I will add the other optic in this port. This is the 1510 optic, and I will just get a cable and connect it to the 4090 port here. The COM port is the port where you most of the time connect it to your dark fiber. So this will go from one building to the other building. We'll do now, of course, because this is a lab, we just connect this port to our other mux on the other side, and we plug this also on the COM port. With the digital power meter we can measure, and I hope it's good visible, the 4090 lights. I always have to check where the light is coming out, if it's this side or this side. And you can see it's minus 15, and that's more or less a correct value because we added 15 dB of attenuation to it. In the other Cisco switch we'll plug the optics. I'll get another cable. This was the 4090. You can see the light is orange now, so the link is coming up. Can take a bit till it's green. I'll connect the other one. I'll just make sure that this is the 1510. You see now it's getting green. And the same happens here. So just to summarize everything here, what we've made, we got a simple Cisco switch. We put two colors in here. The colors are multiplexed together on this line. This fiber can be up to 200 kilometers. We got 2 gig we put in here. On this fiber you got 2 times 1 gig. That will be transported over to the other mux. We put attenuation on it to make sure it doesn't have too much light coming into the optic. In this side it's multiplexed, and we put it back to the switch again. So we got 2 times 1 gig over this single fiber within 3 or 4 minutes. Thanks.